Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. Thank you for attention to this presentation. I will presentation in this paper about manufacturing grid hybrid, a new material made from rice husk as sugarcane bagasse and reinforced glutinous glue as noise absorption. Noise pollution is one of four main types of pollution. A major environmental problem is affecting the health and well-being of millions of the people in Indonesia's major cities. Long-term noise exposure can be caused by various health. It is very important to produce cost-effective and environmentally friendly material that can reduce noise pollution. Currently, other alternative materials are needed, such as the use of natural fibers to produce environmentally friendly composite materials. The use of the natural fiber, such as Bagasse rice husk, has great potential as a substitute for expensive synthetic fibers. Abundant material, low processing cost, and natural cellular structure, which can effectively nourishing absorbing. Natural fiber waste in the form of bagasse and rice husk is widely available in Indonesia villages. The benefits of the natural fiber are not widely known. A lot of it just wasted. Although it's not an environmental problem, the natural fiber waste can be used as a composite, so the resulting products will be of economic value. The use of natural fiber is not to provide a reinforcing effect, but no strengthen the mass of the composite material. It has low strength and stiffness, which is very good for a neat acoustic panel. The fibrous material in the mixture of bagasse rice husk ice with glutinous glue adhesive forms into a composite with internal pores can be made as a ferrous sound absorbing material. The characteristic is using this material are low density, large lumen, and thin wall structure, which is beneficial to increase the friction between the acoustic wave and fiber surface. In this paper, noise absorbing testing is carried out using a 2-microphone impedance tube ICIMECE2050 to determine the optimum process parameter for a composite sound absorbing material mixed with bagasse rust as with glutinous glue adhesive. Sound absorbing properties of composite material and airflow resistance and cavity thickness were obtained after comparison and analysis. The purpose of the study was to utilize bagasse and rice husk as waste with glutinous glue as a natural fibers composite in the form of a green hybrid new material method. The bagasse that has been washed with clean water. There in the sun, then crushed using a shrinking machine to obtain a vertical size of 40 misses. The rice husks are first cleaned with clean water, dried in the sun. After drying, it is burned to get rice husk ash. These materials are mixed according to the treatment composition to clarify the acoustic effect on the materials. The manufacturing of natural fiber composite specimen went through 3 stages consisting of first the bagasse and then meshes using a fiber surrounding machine. Second, the rice husk and then burned to obtain ash. Third, making composite specimen using glutinous glue reinforced, and testing composite as absorbent salt. Testing procedure. The ISO standard 10534 evidence tubes are designed with a certain length to produce a flat sound wave between the source and the sample. This tube with circular cross-section to choose a length greater than 3 times the tube diameter. Shown insulation testing uses the principle of transmission loss by measuring the reduction in shown transmission received by the sensor after penetrating the material that adopts the ESTM E1050 standard. The testing is carried out by surrounding a sound source at a certain frequency and measuring it with a sound level meter at the other end, comparing the test result with a large sound intensity if the test object is not installed as a barrier. The result of the compaction of Bagasse and rice husk using glutinous glue as reinforcement obtain a brownish colors. Drying at the beginning naturally for 20 hours and continue drying using the oven. Oven drying starting from 40 degrees Celsius to 100 degrees Celsius through the technique of increasing the temperature every 10 degrees Celsius after 10 minutes of drying. The result of the color of the specimen are brownish white. The application of glutinous glue on the composite material where is the optimum noise absorption obtained as much as 10%. Giving glutinous glue at 10% form is wider and more even curve than giving glutinous glue at 20.5% and 15%. The higher absorption is allocated at the frequency of 4,800 Hz and a short absorption coefficient of 0.40. The characteristic of the noise absorption curves is explained that optimal noise absorption coefficient is the ratio of material composition that mixture is 70% of Bagasse and 30% is rice husk. The Bagasse particle will increase the number of cavity or porous so that they have a larger volume of space. The optimal noise absorption is obtained that 3 to 4 compaction mean that the porous forms are much more numerous and have larger cavity. The noise absorption curve for variation in the thickness of composite specimen shows that the 2.5 centimeter thickness specimen had a better noise absorption value. The noise absorption coefficient in the 2.5 centimeter thickness acoustic cell indicate that the low frequency noise absorption of 800 Hz can absorb it up with in absorption coefficient of 0.92, while for high frequency it then absorbed with absorption coefficient of 0.6. The variation of thickness and compaction of the composite material specimen is an important factor in determining the acoustic efficiency in the same composite variation. It can conclude that the noise reduction coefficient increase in the presence of various material. Thank you for listening. My all those we have shared beneficial for all of us. Thank you.